Sixth grade lesson 10.1 is doing the area of a parallelogram. And before we get too far into it, let me dust off some cobwebs. We've talked about perimeters of shapes, and now we're going to be talking about area of shapes. Recall that a perimeter is the distance around the outside of something. Like if I were running around the outside of a park, what's the distance I would run if I was going along the edges of the park? Or if I had a garden and I wanted to put a fence around the outside of it, that would be perimeter. Area would be a scenario like at the park, they want to plant some grass seed and they want to cover the whole inside of the rectangular park. Or your garden is rectangular shape and you want to make sure you get water across the whole field of it, or your floor is rectangular shaped and you want to put new carpet down on the entire floor or tile down on the entire floor. Those would be area scenarios when you're covering a flat surface, is area. Let's take a look a little bit at how we could figure out area. So let's say we have this rectangle here, and if there are all these tiles inside of it covering the floor, how many tiles are there? One way we could find area is if it's already broken down for us, we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 tiles inside of it. Okay, so that's one way we could do it. And if they didn't break it down for us, we could potentially say, okay, well, there's 4 pieces here, so let me split this way into 4 equal pieces. And there's 3 pieces this way, so let me split this into 3 equal pieces this way. And then I can count them. I could do that. What you would start noticing, though, is if it's 4 this way and 3 this way, that's 4 in a row 3 times. 4, 3 times, 4 times 3. So when we're calculating area of a rectangle, we do length. I should have moved this over. Hold on just a second. Okay, that's better. Length times width. L for length times W for width. And you will frequently see this. Remember, when we have 2 variables next to each other, we don't necessarily have to put the multiplication symbol. So you will frequently see it written like that. A equals LW. Area of a rectangle equals length times the width. You find the length of the rectangle and the width of the rectangle, and that's the area. And you've probably seen this before. So the rectangle part makes sense. Now, let's go ahead and extend this into what happens with parallelograms. Okay, let's say I have this parallelogram, and just a quick review, parallelogram is a 4-sided figure that has 2 sets of parallel lines. This is one set of parallel lines, and this is the other set of parallel lines. Those lines will go on and on forever, never touch each other if they were to extend. So a parallelogram has 2 sets of parallel lines. I always think of them as leaning over rectangle, right? It's a rectangle that's just kind of leaning over like it's wanting to fall down. Parallelograms are just leaning over rectangles. And I have this parallelogram with a measurement of a 9 here at the bottom. We'll call it the base of it. The base of it has a 9. And the height of this parallelogram is 4. Now, the cool thing about a parallelogram is I can cut and readjust it into a rectangle. Watch. I can take this triangle off of here. And because that's parallel on the other side, I can just take that over here and reattach it to that side. And then look at there. I have a rectangle that has a base of 9 and a height of 4, or a length of 9 and a width of 4. So because that works on all parallelograms, then your formula for finding the area of a parallelogram is basically the same as finding the area of a rectangle. Only we use different words because we're finding the height now instead of the width when it was just a rectangle, the width. We're finding the height. So we're not going from here to here. We're taking from the base up to straight up until it meets the roof. Okay? So it's base times height. It is the same calculation. It's the same thing. So I just kind of take this formula, and you'll see it written this way, base times height, BH. I kind of take this one and just apply it to rectangles and squares and parallelograms in general, instead of memorizing 3 different formulas. They're all kind of the same, or they are the same. So I take this formula, area equals base times height, and I apply that to rectangles, parallelograms, and squares, because it would work on a rectangle, right? The base is 9, the height is 4. Parallelogram, base is 9, height is 4. So the area of this rectangle, 36, the area of this parallelogram, 36, and it would be the same, right? Because we're just taking this part of it and knocking it over there. Okay, so let's look at an example of calculating with this. I put the formula here written out, area equals base times height. This is for area of a parallelogram. Can be used for rectangle and square as well. Usually you'll see it written A equals BH. That's the formula they're referring to. The steps for solving these are really very simple. Just write the formula, enter the dimensions, meaning the measurements for the parallelogram you're looking at, and then calculate it. So they've written the formula. Then they replaced the base with 6.3. That's the base, length base, same thing. Then we're going to replace the height. That's 2.1. And then all we need to do is the multiplication. And we get 13.23 meters. Now, keep in mind, when we did this, this was meters times meters. Remember those exponents we learned? That when we do a number times itself, well, in this case, it's a variable, a letter by itself, or a measurement times his own self. We do it to the second power. So all area measurements are going to be in a unit to the second power. You can read this as meters squared, because to the second power is sometimes said as squared, or square meters. You'll hear it said that way, or meters to the second power. You'll hear it all of those ways. All area calculations are one dimension times another dimensions, 2 dimensions, a flat figure. So you're going to have a unit to the second power as your label all the time. So in here you see them write square meters, meters squared, square meters. Answer 13.23 square meters. And that's it. That's it. You write the formula, you enter the dimensions, and you calculate it. Let's look at another example. Okay, here are 2 more examples, though I'm feeling like you're probably feeling confident here. The only thing here is they do give you another formula. This formula, like I said, it isn't one that you necessarily need to remember, because this one still works for squares, base, height. But the reason you see this sometimes, it's important to know what it's referencing. It's saying the area of a square is one side times the other side. Because remember, squares have the same measurement of sides, so we can use the same variable for one side and the other side because they're the same measurement. And s times itself twice is s to the second power. So in this case, we can say 9.5 is one of the sides to the second power, and 9.5 times 9.5 calculates out to 90.25. And that is centimeters times centimeters, so it's centimeters to the second power. Now, what if I had forgotten the formula for a square, a equals s to the second power, but I really remember area equals base times height for parallelogram? Remember, squares are just one form of a parallelogram. They are a 4-sided figure with 2 sets of parallel sides. I still could use the parallelogram formula on it if I wanted to. Base times height, where my base is 9.5 and my height is 9.5. And look at this compared to this, 9.5 to the second power. You're doing the same calculation. So just keep that in mind. Parallelograms, base times height. Squares are considered parallelograms. Rectangles are considered parallelograms. So you can use that same formula on all of those. So just remember, so here we have a parallelogram. Oh, this time they give us a little bit of reverse. We have to do some little bit of mystery solving. Parallelogram has an area of 98 square feet. They told me what the area is. I don't have to solve for area. Oh, that's awesome. Thanks, guys. And a base of 14 feet. Okay, cool. What is the height? Oh, I'm missing a piece of information. All right, fine. That's fine. Write the formula. That's step 1, no matter what. Fill in the dimensions they gave you. Make sure you put those dimensions with the correct piece of information they're giving you. A is not unknown this time. I do know what A is, so I'm going to put for A 98. My base is known, so for B I will put 14. My unknown is that height. That's my variable. Now hopefully when I write it out this way, your brain starts to kind of go, oh, 98 equals 14 times h. This is one side of the scale, this is the other side of the scale. Oh, there's my variable. He's hanging out with this multiply by 14. I want that variable to be all alone so I know what he is. I'm going to use an inverse operation. Opposite of multiply by 14 is divide by 14. You're just going back to those one-step equations we did a little bit ago. 14 divided by 14 leaves you with 1h, and 98 divided by 14 is 7. I had to do a little bit of math lab work over there, but it worked. So the height of that parallelogram must be 7 in order for 14 times 7 to equal 98. 14 times 7 to equal 98. So if they give you the area and only one of these pieces of information, well, that's okay because you are a really good detective now. You know those one-step equations to use inverse operation to isolate your variable, do the opposite calculation in order to get that variable by himself on his own side of the scale. So use that skill if they give you that. That still starts with writing the formula. So your steps are write the formula, enter the dimensions provided. Sometimes the dimensions are the base and the height, but other times they might give you area and the height, but not the base. Or they might give you the area and the base, but not the height. So make sure you're plugging in the right dimensions that they give you for each of the variables. A stands for area, B stands for base, and H stands for height. And then you just calculate. If it's A equals and you have the two numbers, then you're calculating just the multiplication. If they give you area and you have one variable over here with its coefficient, then you're going to divide to get rid of it, to isolate your variable, right? So that's it. That's all this lesson is. I think once you get moving on those, it's all going to come together. It's all going to make sense. You're going to find this one pretty easy, I think.